Okay, today we will be doing two topics, and combinations and series. Okay, so before starting permutation and combinations, you need to know the factorial notation. I believe that this is all the basics which you need to build before you can jump into the permutation and combination topic. So you know that n factorial is factorial is defined as n the number of multiplications you do till from the number till 1. So it's like n factorial is equal to n times n minus 1, n minus 2, n minus 3, all the way to 3 and 2 and 1. So there's an example here. I've given 5 factorial. So 5 factorial is basically 5 times n minus 1, 5 minus 1, which is 4, 5 minus 2, which is 3, and 2 and 1, which is equal to 120. Understood this, right? You can unmute, you can talk. It's fine. Okay, we'll just move on. I believe you understood this topic. This is basic. So, what is the value of 0 factorial? So, this is something we know that 0 factorial is 1. So, I will just give a little out of topic. Go a little out of topic and explain why 0 factorial is 1. Because when I was studying about this, I got interested and I didn't know. Sorry, I think there's a lot of background noise. I couldn't hear.
Oh, there we the music.
Okay, I think I'll just explain why 0 factorial is 1. Um, so you know that 1 factorial will be 1, 2 factorial would be 2, 3 factorial will be 6, 4 factorial will be 24. Okay, so what happens is when you go to the 0 factorial, you just follow the pattern. There's a pattern you can see here. So 24 divided by 4 is 6. 6 divided by 3 is 2. 2 divided by 2 is 1. And 1 divided by what's the pattern? So it's basically 1 divided by 1, which is also 1. So that's why you get 0 factorial as 1. Okay, so it is just a simple pattern which you can recognize. When I learned about this externally, it was very interesting because I didn't know that why you would just tell any 0 factorial as 1. So I'm just giving you some additional knowledge over here. Okay, now there's a practice question over here. I think you can just try to do it and let me know the answer once you're done. This is on the topic of arrangement, which will use
Okay,
the
okay.
factorial concept. So you need to use factorial concept to do this question.
Okay, I'm solving it. I'm solving it.
Yeah, yeah. Sure. Take your time. Sorry, I made a mistake over there. I'm also solving it. I think you can leave part B because part B is in combinations chapter. So we will, after we are covering that, we will do a different question on that. So have you found the answers?
Yeah.
Is it matching with mine? So I have to put it in.
Yeah, I think so. I think so. Yeah.
Okay. Then I think you're confident with the arrangement concept. So for this part two only, I'll just explain for the other students. So what you do is you're grouping all the five together, and the rest of the three will be grouped separately. So what the trick I use here is there you can alter any position between the five, which is basically the 5 factorial which I did here. So you think of this, the book can be placed in five positions. Each book can be placed in five positions. And 4 factorial is because this whole set can be put here, 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 or here. So that's why 4 factorial. So hope you understood this. We'll move on now. So permutation and combination. So basically both are mostly similar, but you need to know where you are going to use it. Mainly, these questions will always ask you about find the number or the number of attempts you can make or number of passwords, like something like that. So there will be the number you need to find, the number of something you need to find. But permutation is when it is used when there is an order to follow. So you need an order. So basically, if there's a different order, the whole result might change. So when there is that kind of case, you use permutation. So for example, when creating numbers, generating any numbers using separate digits, there should be an order because when you use the say, if randomly you're selecting the numbers from the list, from the digits, and then you're placing it at different positions, different numbers can be formed when you're kept at different positions. So that's why when like
So
these
I
kind
want
of
to answer it.
problems come again.
I said I got it.
Okay, yeah. So at different positions, the result might change. So you need to use permutation over there when there's an order to be followed. Combination is when there is no order to be followed. So there is no order. So basically, you're randomly selecting some students from a group. Then that is called. Then that is when you use combination. Okay, and these are the two formulas. For one is for the permutation. You write NPR, which is n permute r is equal to n factorial over n minus r factorial. N is basically the number of total number of uh, items or the population, and R is the number you're going to choose from it. So basically, the number of attempts you're going to take from the sample. This is basically the population and the sample. Okay, so I'll just write it. So this is the population, the biggest, and this is the sample you're going to take from the population. And n choose R. Okay, n choose r is n factorial over n minus r factorial times r factorial. The only difference is this times r factorial, which is removed in the permutation formula. So these two are the crux of this whole topic. So I think mostly we're done for this topic. I'll just give you a practice question over here for permutation and combination. You can just try out. So basically, this topic is a very small one because only two of the two topics, subtopics are included, permutation and combination, and you need to know how to arrange things in different ways. So that's all. That is coming in the factorial concept. Right. So could you tell me if we are going to use permutation here or combination? Even though I written it permutation, could you tell me why it is we use permutation in this type of in this question? Seth, either. You can unmute. Okay, so basically I'll just tell it. Because there is a character and you need to find a password. So each position, there is an order to be followed in a password. So that's why we use permutation over here. So what you do here is the number of passwords that can be formed is from these 10 characters, you can write 10p5 because it's a 5 character password. You need to choose a 5 of the characters and then you need to make it in a specific order. So the different order gives you a different number of passwords. So that 10p5 would be 30,240. And find the number of passwords that can be formed if the password has to contain at least one symbol. So this means that one symbol is already been used. The rest of the 9 characters, you can choose any of the. So basically, I'll just write like this. So one is used, so it can be in any of this place. Two times 9p3. 16. So this how because this four tells us that the symbol we chose is used in, it can be used in all the 4 places, and 9p3 is with the rest of the characters you choose 3 characters from it and use it. And find the number of passwords that can be formed if the password has to start with 2 letters and end with 2 symbols. So that means that for the first two blanks, it should be from the letters. So 6p2 times, and the last two should be from this, which is 4p2. 6p2 times. It will be 360. So you can leave the part B. Part B is from combinations, or you can just try it out. Let's just try it out. Find how many teams have the same number of doctors as teachers. So there you need to just list them down, like because there can be more doctors and teachers in a team of 8 people. So I'll just write this answer over here. So you need to choose 8 people, right? And same number of doctors as teachers. So let's take one doctor and one teacher. So 6 police officers. Teacher, doctor, police officers. So this is one set. If you take two and two, four is done, and there will be two police officers. Three and three. No, wait, sorry. Two will be four, and then four police officers. Three and three, six. Two police officers, and four and four. You can take, and then zero. Okay, that's the maximum you can take. So you need to just find for all of these, and then add them up. So the answer would um, be 5 p1 times 4p1 times 6p6 plus 5p2 times 4p2 times 6p4 plus 5p3 times 5p 6 4p3 4p3 times 6p2 plus 5p4 times 4p4 times 6p0. So same event. So one more thing, when to use the multiplication and when to use the addition. So whenever there is an and, so this whole set will come under one. So one and six, right? So whenever there is an and component, then you use multiplication. So then these two sets, this can come or this can come. When there's an or variable, then you use add. So you can remember and to be um, multiplication and or to be addition. So these two are different sets. So that's why. So these four are different sets. That's why we add the quantities, and inside the brackets we multiply because it's from the same set. Got it? Okay. Now I'll just move on. There's another question here on combinations. So this is from combinations as before. So this should be actually combination C. Sorry, I forgot. This should be C because they are choosing, right? Choose means you use combination. Sorry for that mistake. Yeah. And now this combinations question. A team of 6 members is to be selected from 6 women and 8 men. Number of teams selected. So this is a straightforward question. This total number will be 14. Choose 6. So this will be 3003. And the number of different teams that consist of 2 women and 4 men. So the team should have 2 women at least. So that means 6 choose 2 times 8 choose 4. Since this is one set, that's why we are multiplying. There's an and factor here, so that contributes to multiplication. And the number of at least no more than 1 woman. So there's only 1 woman. So that no more than 1 woman can also mean that there can be 1 woman, or 0 women. So you need to consider both the factors. So that's why we will be doing for both. So 1 woman will be 6 choose 1 and times 8 choose 7 plus 0 women would be 8 choose 6. So then you can just find the answer here. So now we will be moving on to series. So in chapter 12 series, it's also a simple topic. There's two components to it, arithmetic and geometric series.
But that's good.
Yeah, I thought were you disconnected? And meanwhile, did you understand?
It was my network.
Did you see this question or I think I just explained without you.
It was my network. Network.
Okay, I'll just continue.
No, continue.
Okay. You understood this, right? How to use combinations here. Okay, then I'll just continue with series. So series is also a simple topic. There's two components, arithmetic and geometric series. And this is one of the important topic, the binomial theorem. So this binomial theorem, you can see that the general formula to expand a plus b to the power n is a to the n plus n choose 1. So this thing means n choose 1 and this means n choose 2. So how I remember is first you take a to the power n and the last will be b to the power n. So these two are these two you can remember easily. The middle terms will be n. You start from n choose 1 and then you will give the brackets, and for the first variable a you need to do a to the power n minus 1. And for b, you just copy the 1 on the exponent. So b to the 1, which is basically b. And then for you just write plus n choose 2, a to the n minus 2, and then b squared. And then till the n, and then till you just add all the terms till b to the n. So that's your general formula of a binomial theorem. So it's just you're expanding this here, expanding this to this form. Okay, so there's a question here, so I think this is a little blurred. I'll just write the question here: 1 plus x by 4 to the 8. So they're asking you to find the first four terms in the binomial expansion in ascending powers of x. So ascending powers of x, you start from the first term till the last term, and giving it in the simplest form. That means you need to make it into the simplest form by expanding all the inside parts. So we'll just do it. I'll just do it here. You can just try it out without seeing. So this is the expanded form. You can just simplify from here. So this will be 1 plus 8. So it will be 2x plus 8 choose 8 choose 2 divided by 16. 4 squared will be 16. So that is 7 by 4x squared plus 8 choose 3 times divided by 4 cubed, 64. So that will be 7 by 8 x cubed. So these are the four terms. And when you're writing the answer, it should be in this expanded form. You should not just write the first term, second term, third term, fourth term.
Okay.
And part B is basically you use this expanded version to for you to solve this. So part B is 1.025 to the 8. You can expand this as 1 plus 0.025 would be 1 by 40. So wait, how do you do this? 1 plus 1 by 40. So 1.025 is what? 025 41 by 40, right? So you can convert this into x by 4. So you need to convert this into x by 4. So how for that you can just write this part. I think you can write this as, so basically what they're asking is to estimate the value of this. So basically you need to just use this form. They are just asking you to use this form. I think there's some error, or you need to just make this 1 by 40 into 1 by 4 and then use this expanded form and then substitute it and then solve it. Okay, so basically they are telling that 1 by 10 over 4. So you can write this as 1 by 10, 1 by 10 over 4, which is 1 by 40 to the 8. And then your x value will be 1 by 10. So then you just write it 1 plus 2 times 1 by 10 plus 7 by 4 times 1 by 10 squared plus 7 by 8 times 1 by 10 cubed. So this what you get the answer, you just round it off like to 4 decimal places. Shall we move on? I think you asked some doubt. Sorry, could you unmute and ask your doubt? Seth, are you there?
Nah, I couldn't finish. I want to finish writing the procedure.
Come again? I think you asked yesterday's doubts, right? There's
Yeah.
some doubt from
You want me to
yesterday.
beat again, but my chance goes
Okay, I'll
to the
clear that
solution.
after the lesson. I'll clear it. Okay. After.
Okay. About the
Okay.
previous solution, I couldn't finish. Let me see it.
This one.
Yeah.
You didn't understand this one.
No, I couldn't finish writing it.
Oh, okay then. Yeah, you can just take time. You can just copy from here. So I didn't give you this answer. You just write it in the calculator. Type it in the calculator and then find it. So you understood, right, why we wrote 1 by 10 over 4? Because we need to get to the x by 4 thing to use it.
Oh.
So to the 4 decimal places, it will be 1.2184. So this is to the 4 decimal places. So rounded off value.
Yeah, I'm done.
Okay then. Now we will move on to arithmetic progression. So arithmetic progression is basically a series progression that has a common difference between the one term and its next term. So given an arithmetic progression, the nth term can be defined by a n a plus a. This is the first term. So first term in the series plus n minus 1d. So the number n represents a number of terms. D represents the common difference, and A1 represents the first term in the sequence. First term in the sequence. So then you need to also know the sum of the first n terms of an arithmetic progression is defined by this formula. So this formula also you need to know. N by 2 times 2a1 plus n minus 1d. So both these will be given in the formula sheet, but it's better to know it by heart so that you when you're doing it when you're doing the questions you can do it fastly. So then there's a practice question here. So I've just practice question. So here for part I, show that the fourth term can be written as this. So the first term they have given, so this is a1, and the common difference d is equal to log 2x. So first what you do is you need to find the nth term before you can find the fourth term. So nth term will be from the equation here. So it will be a1 plus n minus 1d. So a1 is log 227 plus n minus 1 log 2x. So then you can just leave it as it is first. Then you can say fourth term will be log 227 plus 3 log 2x. No, wait, sorry. Fourth term, you write it in the other form. Yeah, it should be like that. Okay, sorry. It's 3 log 2x. 3 log 2x. So then they're asking you to convert it into this. So from the laws of logarithms, you can see that when you add any log with the same base, you can multiply the inner terms. So before doing that, you can also bring this 3 to the top, which makes it log
Hey, so the guy
2x
is still
cubed.
teaching. But what about that move? I'm making.
So then
It's not.
what happens here? Then you can multiply the inner terms, 27x cubed. And that is the show question over here. So given that the fourth term is 6, find the exact value of x. So part 2 is straightforward. Log 2 27x cubed is equal to 6. So then you make 27x cubed equals to 2 to the power 6. X cubed will be 2 to the power 6 over 27. X would be 2 to the power 6 divided by 27, which is 64 over 27. And then when you cube root the answer, you will get 4 by 3. So that's your part 2. Do you understand?
Yeah.
Okay. Shall we move on to geometric progression?
Okay.
Okay, so geometric progression is another type of series progression which depends on a common ratio. First we saw the common difference. Now it's a common ratio between one term and the next. So the nth term of the geometric progression can be defined as Tn. So this the nth term is A. A is the first term in the sequence, times r to the n minus 1. So you know that now here n is number of terms from previously also it's the same terms. A would be the first term in the sequence, first term, and R is the common ratio. So the sum of the n terms in of a geometric progression is defined by Sn a to the 1 minus r to the n my 1 minus r. So this is the sum formula for a geometric progression as we saw before. So there's an additional formula you need to know here for a geometric progression that has a ratio between when the r the common ratio is between negative 1 and 1, then there is a sum to infinity. So sum to infinity is basically use this formula a over 1 minus r, sum to the infinity. So this should be not n, this should be infinity. Okay. So these are the three main formulas for geometric progression. Of course, there are more, but they are not in syllabus. So for syllabus, this is enough for you to remember. They will give you in the formula sheet also, but it's easy. It will be better if you can by heart all the formulas. So here's a small practice before we end. I think we are done with today. Today topics were also small only. So in this, okay, I'll just draw. So they gave the first term as 360, common ratio as 7 by 8. Give your answers to three significant figures where appropriate. So the 20th term in the series will be what you do is first you find the Tn, which is a times r to the n minus 1. So a is 360, r is 7 by 8, and then n minus 1. So T20 would be 360 times 7 by 8, 19. So that would be 7 by 8 to the 19. So it's about 28.474 which when you write it in three significant figures, it will be 28.5. 28.5. The sum of first 20 terms of the series. The sum is you can just use the sum formula for the 20 terms. It should be a time. So as you can see, a times 1 minus r to the n over 1 minus r. So it's a good practice to write the formula, then substitute the values. So sometimes if you miss any values, then it will be you will get it wrong. So it's best to write the formula, then write the values. So here a would be 360 times 1 minus 7 by 8 to the 20 by 1 minus 7 by 8. So whatever the answer, that's you need to convert it into three significant figures and sum to infinity. You can see that this is between the r is between negative 1 and 1. So then there will be a sum to infinity. In some questions, they will give you the series and ask you why there is no sum of infinity. Give a reason for that. Though the reason is the common ratio is not between the negative 1 and 1, then there is no sum to infinity for that series. Since here
Okay.
7 by 8 is less than 1 and greater than negative 1, there is a sum to infinity. So you can find the sum to infinity by a by 1 minus r, which is a is 360 over 1 minus 7 by 8. So whatever the answer, that's for part C. So this is part A, this is part B. part B, and this part C. Understood?
Yeah.
Okay, then there's another question also, I think, here. So it's depending on the log. So I'll just do this question also. The first term they have given as it's a geometric progression. The first term is log 227 and the common ratio is log 2y. Find the set of values of y for which the geometric progression has to sum to infinity. So what you do is, you know, the criteria for a sum to infinity to occur in that progression is that the common ratio should be between 1 and -1. So then you can just, the common ratio is already given. So log 2y should be between 1 and -1. So then you can just bring in the 2 over here, 2 to the 1, and here it will be 2 to the -1. Y would be 2, y would be between 2 and half. Got it? So this is a set of
Yeah.
values for y. And then part 2, they are asking find the exact value of y for which sum to infinity is 3. So sum to infinity you can find by a over 1 minus r. So a is here log 227 and 1 minus log 2y, which is equal to 3. So now you just solve this equation and then you will get what is the value of y, and it should be in the exact value, so you make sure you keep it in the exact value and no decimals should be there. Okay, got it.
Yeah, got it.
Okay, then I think we are done with today. Thank you for joining. I'll just clear your doubts now.